In today's video, we are going to study finding areas between curves. So what we're going to do is we're going to look at a method of evaluating the area between two different curves, and then look at a few examples of calculating the area between curves. Let's suppose that we are given two curves, f of x and g of x. Obviously, in our example, f of x is greater than or equal to g of x. Let's say this is A, this is B, and we want to find the area between f and g over the interval a to b, right? So we're looking for this area in here. Right? Well, we know how to find the area under f. Right? So area under f would be this blue. And that is given by a Riemann integral. Integral from a to b, f of x dx. Well, if we take out the area under G now, right, this green area, let's say, what we will be left with is the yellow shaded between F and G. And we know area under G, again, is a Riemann integral, integral from a to b, of g of x dx. So what we can conclude is that the area between f of x and g of x would be the area under f minus the area under g. And of course, since the Riemann integral is what's known as linear, we can write this as a single integral from a to b, f of x minus g of x dx. And that is our formula for finding the area between curves. If f and g are both continuous functions, and f of x is less than or equal to g of x over the interval a to b, then the area that is bounded by the curve y equals f of x and the curve y equals g of x over that interval is given by area equals the integral from a to b, f of x minus g of x dx. In other words, it is the integral over the interval of the larger function minus the smaller function. We will now look at examples. For the first example, we're going to go ahead and find area bounded by the graphs of a half x plus 3 and negative x squared plus 1, and the lines x equals negative 2 and x equals 1. All right, the first thing we want to do is let's see if these two curves actually intersect anywhere. So to do that, recall you just set them equal to each other and solve. So a half x plus 3 is equal to negative x squared plus 1. This means x squared plus a half x plus 2 is equal to 0. So x, let's multiply everything by 2 first, actually. So we'll have 2x squared plus x plus 4 is equal to 0. Using quadratic formula, negative b plus or minus the square root b squared minus 4 times a times c. I actually did c times a here, so let's fix that. A times c all over 2 times a. Notice that under the square root, we're going to get a negative number, which means that there is no solution. So these two curves will not intersect at all. Our interval is negative 2 to 1. We have to determine whether f or g is larger. Pick any value between negative 2 and 1. The easiest value in there is 0. F of 0 is going to be 3. G of 0 is 1. Therefore, f of x is the larger function over this interval. Therefore, the area is the integral from negative 2 to 1, f of x, which is a half x plus 3, minus g of x, negative x squared plus 1, dx. This is the integral from negative 2 to 1 of x squared plus a half x plus 2 dx. All right, we're going to use the fundamental theorem of calculus here. Remember that means that first we need to find an antiderivative. So power rule, we have x to the 2 plus 1 over 2 plus 1 plus 1 half times x to the 1 plus 1 over 1 plus 1, and then plus 2 times x. And then we evaluate that, x equals negative 2 to 1. We get x cubed over 3 plus x squared over 4 plus 2x evaluated from x equals negative 2 to 1. When x is 1, we're going to have a third plus a fourth plus 2 minus, now when x is negative 2, negative 8 thirds plus 4 over 4, which is 1, minus 4. And this whole thing will evaluate out to 33 over 4. So that is the area between f and g, 33 over 4. For our next example, we will find the area bounded by the functions f of x equals 5 minus x squared and g of x equals 2 minus 2x. Here we're not given an interval. So what that means is we need to find the points where these intersect, right? And then that will be our interval of integration. So again, to find intersection, we just set the two functions equal and solve for x. 5 minus x squared is equal to 2 minus 2x. So what we get is x squared minus 2x minus 3 is equal to 0. This factors to x plus 1 times x minus 3 is equal to 0. Right, so that means that x is negative 1 and x is equal to 3. So our interval of integration will be negative 1 to 3. Once again, 0 is in there. F of 0 is equal to 5. G of 0 is equal to 2. This means on this interval, f is once again the larger function. Therefore, the area is the integral from -1 to 3 f of x, which is, 5 minus x squared, minus g of x, dx. It's the integral from -1 to 3. 3 plus 2x minus x squared dx. Again, using fundamental theorem of calculus, first find an antiderivative. 3x plus 2 times x to the 1 plus 1 over 1 plus 1 minus x to the 2 plus 1 over 2 plus 1 evaluated. X equals -1 to 3. This is 3x plus x squared minus x cubed over 3 evaluated. X equals -1 to 3. Plug in 3, we're going to get 9 plus 3 squared is 9 minus 3 cubed over 3 is 3 squared, which is 9. Minus, now when x is -1, -3 plus 1 plus a third. And this evaluates out to 32 over 3. And for our final example, we will find the area that is bounded by x squared minus x and 2x for -2 less than or equal to x less than or equal to 3. Again, the first thing we want to do is check to see if these two curves are going to intersect at all in this interval. Right, so x squared minus x is equal to 2x. This means x squared minus 3x is equal to 0. So x times x minus 3 is equal to 0. And we get the solutions x equals 0 and x equals 3. Now, x equals 3 is the end of our interval, so really it doesn't tell us anything. However, 0 is in that interval. So this does intersect over the interval -2 to 3. What this is saying is that we actually have two separate areas that we have to calculate. One from -2 to 0, and then one from 0 to 3. So two intervals. First, look at -2 to 0. We'll use the number -1. So f of -1, we get -1 squared is 1 minus -1, so that's 2. G of -1 is 2 times -1, so -2. Over this interval, f of x is greater than or equal to g of x. Now we look 0 to 3. Let's use 1 in there. So f of 1 is 0. G of 1 is 2. So over this interval, g of x is our larger function. Therefore, the area will be the integral from -2 to 0 of f of x minus g of x, then plus the integral from 0 to 3 of g of x minus f of x. First integral will be x squared minus 3x. Second integral will be the exact opposite. So it'll be 3x minus x squared. Again, looking at the first integral, we'll have x to the 2 plus 1 over 2 plus 1 minus 3 times x to the 1 plus 1 over 1 plus 1. That will be evaluated negative 2 to 0. Then we get plus 3 times x to the 1 plus 1 over 1 plus 1 minus x to the 2 plus 1 over 2 plus 1. That is evaluated x equals 0 to 3. It's x cubed over 3 minus 3x squared over 2 from negative 2 to 0 plus 3x squared over 2 minus x cubed over 3 evaluated from 0 to 3. For that first interval, when x is 0, it's just 0 minus 0. When x is negative 2, we get negative 8 over 3 minus 12 over 2, which is 6. Then plus, when x is 3, 27 over 2 minus 27 over 3 is 9. Then minus, when x is 0, it's just 0, minus 0. And this evaluates out to 79 over 6. That concludes this video on the area between curves. In the next and final video in this series, we will go ahead and look at integrals as used in business and economics. I will see you all in the next video.